Black holes are like these giant cosmic vacuum cleaners, right?
Right.
Just swallowing up anything that gets too close.
Yeah.
But
Yeah.
here's the thing. They also have these crazy hot atmospheres, coronas.
Oh, yeah.
And get this, they look pretty similar whether the black hole is tiny or like monstrously huge.
Right.
That's what we're diving into today, folks.
Interesting.
So we're checking out this space.com article. NASA peers into the blistering hot plasma swirling around 12 black holes.
Okay.
It was just published on October 22nd, 2024.
Wow, so recent.
It talks about how NASA's Imaging X-ray Polarimetry Explorer, IXPE for short, is giving us some incredible insights.
Cool.
It's like having, special X-ray vision to study these coronas. But before we jump into all that, can you give us like a quick explanation of what a black hole corona actually is?
Sure. So picture this. You've got a black hole, right?
Yep.
With intense gravity pulling in all this matter from everywhere. This matter forms a swirling disk of superheated gas and dust called an accretion disk.
Oh, I see.
And then you've got the corona, like a blazing halo above and below this disk. It's even hotter than the disk itself. We're talking billions of degrees.
Billions, wow.
It's wild. And it's the interaction between these two, the accretion disk and the corona, that we're trying to understand with IXPE.
Okay, so the accretion disk is like a giant swirling whirlpool of hot stuff, and the corona is like this sizzling, even hotter atmosphere around it. Got it. But how do we actually study something that's like billions of degrees and probably millions of light years away?
Right.
That's where this IXPE thing comes in.
That's exactly.
So what's so special about it?
Well, IXPE uses this technique called X-ray polarization.
X-ray, okay.
Now, you might be wondering, what's that? Think about polarized sunglasses.
Okay, yeah.
Normal light vibrates in all directions, right? But polarized sunglasses only let light through that's vibrating in a specific direction, which is how they reduce glare.
Oh, that makes sense.
So IXPE does something similar, but with X-rays. By measuring the polarization of X-rays coming from the corona, we can learn about the magnetic fields around the black hole and the geometry of the region where the X-rays are produced.
Hold on, you're telling me this satellite is like a giant pair of sunglasses for black holes? That's pretty cool.
It is pretty cool. And the data from IXPE has been amazing. In this study, scientists used it to look at 12 different black holes, both stellar mass and supermassive ones.
Wait, so they didn't just study one black hole, they looked at a whole bunch of them. That's awesome.
Exactly. And not just any black holes, they covered a wide range. From relatively small stellar mass black holes like Cygnus X1 and LMC X1, which are just a few times the mass of our sun, all the way up to the supermassive behemoth at the heart of our own Milky Way, Sagittarius A, which is millions of times the mass of the sun.
Wow.
They even looked at the black hole at the center of the Circinus galaxy, which is 13 million light years away.
So we're talking about black holes of all shapes and sizes. Did they find anything interesting in this cosmic lineup?
They found something really remarkable, actually. Similarities in their corona structures. Despite the huge range of sizes and distances, the coronas of these black holes, both big and small, seem to share a structural relationship with their accretion disks.
So you're saying that these black holes, even though they're so different in size, are basically following the same fashion rules for their coronas. Why would that be?
It suggests that there are fundamental physical processes at play here that transcend the scale of these objects. Even though the environments around these black holes are wildly different, the underlying physics governing their coronas seems to be the same.
So by studying these smaller black holes right in our galactic backyard, we can actually learn about the monsters lurking millions of light years away. That's amazing. Why didn't anyone think of this before?
Well, it's only recently that we've had the technology to do this kind of detailed study of black hole coronas. IXPE is really a game changer.
This is where it gets really interesting. We can use these smaller black holes as like mini labs to figure out what's going on with the supermassive ones.
Exactly. It's like having a miniature model that helps us understand the workings of a much larger and more complex system. This finding opens up a whole new avenue for exploring the universe.
So we've got these smaller black holes acting like these little cosmic laboratories, helping us understand the giants out there lurking in deep space.
Right.
Pretty mind-blowing.
Yeah, it is.
There's another part of this that I find super fascinating.
Okay.
It's those mind-bending concepts about warped space-time and gravity.
Oh, yeah, definitely.
These coronas, they're right at the edge of a black hole's event horizon. That point of no return.
Right.
And it makes me think about another, crazy concept.
What is that?
Warped space-time.
Oh, yeah.
Can you explain what that means
Okay.
and how it relates to, what we're seeing with these coronas?
Yeah, so warped spacetime. It's one of the most profound consequences of Einstein's theory of general relativity.
Okay.
It's essentially gravity.
Mm-hmm.
As we experience it, it's not a force in the traditional sense.
Oh, interesting.
It's actually a curvature of spacetime
Okay.
caused by massive objects.
So a black hole being incredibly massive
Yeah,
creates a huge dent in space-time, right?
exactly.
I'm trying to picture it.
Yeah,
Like if you put a bowling ball on a trampoline, it makes a dip.
that's a good analogy.
Yeah.
That's a good way to think about it.
Is that kind of what we're talking about?
Yeah, basically, a black hole warps spacetime so much that anything that gets too close,
Yeah.
even light, can't escape.
Whoa.
That's what makes them black.
Oh, okay.
But here's the thing, the coronas we're talking about,
Mm-hmm.
those blazing hot plasmas,
Yeah.
they reside just outside this point of no return,
Okay.
the event horizon.
So we're basically observing matter on the very edge of a black hole's grasp. That's intense.
It is.
Whoa.
And by studying the X-ray polarization from these coronas,
Yeah.
we can actually gain insights into the geometry of the space-time around the black hole.
Oh, really?
This could help us test some of the fundamental predictions of general relativity
Mm-hmm.
in a regime where gravity is at its most extreme.
It's moments like this
Yeah.
that really make me feel small,
Yeah.
but in a good way.
Yeah, I get it.
It's humbling to realize, how much we still don't know about the universe
Right.
and how much more there is to explore.
Absolutely.
Okay, back to these black holes.
All right.
So knowing all this about black hole coronas,
Yeah.
what could it mean for us in the future?
Hmm.
Could this lead to new energy sources or ways to travel through space? I mean, everyone wants to know if we can harness the power of a black hole, right?
Well, that might be a bit far-fetched, at least for now.
Yeah,
But understanding these extreme environments
yeah.
could have implications for things like advanced materials or energy production. Who knows what the future holds?
Right. It's like a cosmic treasure hunt, and we never know what amazing discoveries await us.
Yeah, exactly.
But all this talk about black holes, gravity, and extreme environments, it makes you wonder,
What's that?
well, what's it like to be near one of these cosmic monsters? Would it be like a giant whirlpool sucking you in?
Well, let's just say it wouldn't be a pleasant experience.
Probably not.
The tidal forces near a black hole are so strong
Yeah.
that they would stretch you out like spaghetti.
Oh, wow.
It's a phenomena aptly named spaghettification.
Forgetification. Well, good thing we're observing them from a safe distance.
Definitely.
Past the snacks, I suddenly lost my appetite.
Yeah, I can understand that.
Okay, all jokes aside, the implications of this research are incredible.
They are.
If we can unlock the secrets of black hole coronas,
Yeah.
who knows what doors it might open.
It's truly exciting.
Yeah.
Imagine the possibilities, a deeper understanding of gravity,
Right.
insights into the evolution of galaxies. Yeah.
Maybe even clues about the origins of the universe itself.
No, that's what I call a cosmic perspective.
Absolutely.
And speaking of perspective, it's amazing how this research connects the incredibly small, the world of atoms and particles,
Yeah.
with the unimaginably vast, the realm of supermassive black holes.
Indeed. And that's the beauty of science.
Yeah.
It's a constant reminder that everything in the universe is interconnected, from the smallest particles to the largest structures.
So what does this all mean for us, the non-astrophysicist folks who are just fascinated by these cosmic wonders? What's the takeaway message here?
It means that we live in a universe that's constantly surprising us.
Yeah.
A universe full of mysteries waiting to be unraveled. And who knows?
Yeah.
Maybe one day we'll be able to harness the power of black holes for our own technological advancements, just like we've harnessed the power of the atom.
Black hole-powered spaceships. Anyone. I'm calling dibs on the first ride.
Well, that might be pushing it a bit.
But you never know what the future holds.
All right, so we've talked about these mind-bending concepts about black holes, warped space-time, and even touched on the idea of black hole-powered spaceships.
Right.
But I think it's time to bring it back down to Earth, so to speak, and talk about the incredible technology that's making all this research possible. We've been talking about all this amazing stuff about black hole coronas,
Yeah.
but none of it would be possible without the tech, right?
Right.
The technology that's allowing us to study them in the first place.
Absolutely.
So let's talk about IXPE.
Yeah, let's dive into that.
This revolutionary satellite that's giving us a whole new way to look at these cosmic wonders.
It really is remarkable.
We touched on it a bit earlier, but I
Yeah.
think it deserves a deeper dive.
Okay.
Remind us again, what makes IXPE so special?
Well, think about it.
Yeah.
We're measuring the polarization of X-rays
Uh-huh.
coming from objects millions, even billions of light years away.
Yeah.
It's like trying to detect the faintest whisper from across the ocean.
It's mind-boggling.
Yeah.
So how does it actually work? Is it like a giant X-ray telescope in space?
Well, it's not exactly a traditional telescope.
Okay.
IXPE is actually a set of three identical telescopes.
Oh, yeah.
Each one's equipped with this special detector that can measure the polarization of X-rays.
Okay, I have to ask,
Okay.
what do we actually mean by polarization when we're talking about light? I remember the sunglasses analogy from before,
Okay.
but can you break it down a little more?
Sure. So imagine a beam of light,
Yeah.
like a wave traveling through space.
Okay.
This wave can vibrate in any direction, right? Up and down, side to side, any angle
Mm-hmm.
that's unpolarized light, like what we normally see.
Right.
But polarized light,
Yeah.
that vibrates only in a specific direction.
So it's like the light wave is doing a synchronized dance, all moving in the same direction.
Exactly. And certain materials, like those in polarized sunglasses,
Yeah.
they can block light waves vibrating in certain directions. That's how they reduce glare.
Okay, so IXP is using the same principle, but with X-rays.
Exactly.
Yeah.
By measuring which way the X-rays from the black hole corona are vibrating,
Mm-hmm.
IXPE can tell us about the magnetic fields around the black hole
Okay.
and the geometry of the region where those X-rays are produced.
So it's not just seeing the corona, it's about understanding the forces that are shaping it.
Yeah,
It's like having a detective's toolkit that lets us piece together clues about what's happening in these crazy environments.
that's a great way to put it.
This is what I love about science.
Yeah.
It's a constant process of discovery, pushing the boundaries of what we know and how we know it.
Absolutely.
IXPE is like a prime example of that.
Right.
It's not just giving us new answers.
Yeah.
It's giving us new questions to ask.
And those new questions, that's what drives scientific progress.
Right.
They lead to new insights, new technologies, and ultimately a deeper understanding of our place in the cosmos.
Well said. So we're wrapping up our deep dive into black hole coronas. What's the one thing our listeners should take away from all this?
I think the most important thing is that we live in a universe full of wonder and mystery.
Yeah, I agree with that.
There are still so many things we don't know, so much left to discover.
Right.
Every new discovery, whether it's black holes or something else, brings us one step closer to understanding this grand tapestry of the cosmos.
That's a beautiful thought to end on.
Thanks.
To our listeners, keep looking up at the stars.
Yeah, keep wondering.
Keep asking those questions.
And keep exploring.
And keep exploring the wonders of the universe.
Who knows what we'll find?
Who knows what amazing discoveries await us just around the corner.
Exactly.
This has been The Deep Dive, and we'll see you next time for another fascinating exploration.